each of the panelists are going to make some introductory remarks. Although I have to say the first person that's going to do is actually providing a recorded message, and that's Professor Gun Ku, who is the immediate past president of the World Federation of Engineering Organizations. We are then going to hear from Peter Parslow, who's chair of ISO TC211. And so a lot there. And also Nadine, Alameh, CEO of the Open Geospatial Consortium. So the questions that were in the chat all around standards, I'm sure hoping that Peter and Nadine will weigh in on those. Next will be Tony Rinella, Senior Director of Strategic Building Innovation at buildingSMART. And then lastly, Dr. Anaroot Roy, who is the Chief Technology Officer at Genesys International, but he's actually with us today with one of our other strategic partners, and that's AGI, the Geospatial Association within India. And so when I talked before about regional associations with whom we want to create strong partnerships, AGI is one of them. So Anne, I'm going to turn it back to you. We'll hear Dr. Gun Ku's presentation, and then I'll come back on and just make sure, Peter, you're all set because you'll be in the next lineup. Thank you, everyone.
Dear colleagues, ladies and gentlemen, at first, please allow me on behalf of the World Federation of Engineering Organizations, WFEO, to extend the warm congratulations to the opening of this very important event, Spatial Digital Twin, Trends, Opportunities, and the Way Forward. Talking about the digital twin, it is one of the emerging digital technologies which is driving our world into a new digital era. My topic today is digital twin, a tool empowering engineering for sustainable development. At first, I would like to talk about engineering and the digital transformations, and then followed by digital twins definition, benefits, and challenges. Finally, the way out. The only way out is technical innovation. First, engineering and the digital transformation. Emerging digital technologies is driving the fourth industrial revolution and transforming the engineering into a new paradigm. Digital technology such as big data, artificial intelligence, AI, the Internet of Things, digital twin, and the 5G mobile communications, advanced software systems, and so forth, are driving the new industrial revolution and transforming the engineering profession into a new paradigm, which are a paradigm of internet-based, data-driven, AI-empowered engineering paradigm. Digital twin is a very important technology among the emerging digital technologies. Digital twin is a digital reflection of a physical object or system. Digital twin is not a specific technique for specific application. It is a general technology for all engineering profession. It's usually defined as a real-time representation of a physical entity in a digital world. This definition is given by ITU, the International Telecommunication Union. Digital twin is a dynamic, up-to-date replica of the physical assets or a set of assets, a building, a campus, a city, or a railway, a highway, a machine, a production line, or a factory. That brings together design, construction, manufacturing, and operational data. For example, a digital twin of a building lives from the beginning of the project throughout the entire life cycle of the building. The digital twin continues to live, grow, and provide new insights into energy savings, maintenance, and performance. Here you see an example of digital twin. This building is called NEST. That stands for the next evolution of sustainable building technologies, which is located in Zurich, Swiss. The entire NEST building was laser scanned to help create its digital twin. Approximately 3,000 sensors provide data for facilitates management, including temperature, air quality, and more. Real-time and historical data are combined for greater transparency into the performance of the building, and the building information models can be directly loaded into the digital twin. This is cited from Autodesk book. And this paragraph shows a high-level overview of the city-scale digital twin, its main components, real-world data sources, and significant applications by far. So the lower part is the physical world, building, citizens, open data, infrastructure, urban services. And then comes the digital twin platforms, simulation, device management, machine learning, artificial intelligence, data storage, analytics, data synchronization, the digital twin model repository, and so on and so forth. Upon that, there are various applications. Digital twin help us to understand the present and predict the future. Digital twins help engineers accomplish a great deal, like visualizing products in use by real users in real time, building a digital thread connecting disparate systems and promoting traceability, refining assumptions with predictive analytics, troubleshooting far-away equipment, managing complexities and leakage within systems. Digital twin helps to reduce cost, energy, and time while increase reliability, resilience in construction, manufacturing, and operation. Here is an example of digital twin for the Beijing 2022 Winter Olympic. The main stadium area traffic is digital twinned to help the Olympic organizer to manage the traffic and ensure the success of the Winter Olympic just a few months ago. Although there are good benefits could be brought by the digital twin, but there are also challenges to digital twin applications, such as data availability and quality. Because digital twin is a data-based technology, the sufficiency and quality of data are of vital importance for digital twin to reflect the physical system correctly and accurately and timely. Data processing modeling capability, merging or integrating data from different sources with different format and accuracy at different time needs high technical capacity. Although there are already tools available, it is still short of proper digital twin tools for different kinds of applications, and there is a gap in standardization about the digital twin products and the relevant data specifications. Cost affordability. Deploying large amount of sensors may cause significant increase of cost, and reliability, scalability, and security, as well as privacy, also pose severe challenges to digital twin applications. What is the way out? The way out is to maximize its potential by technical innovations. And to carry out technical innovation, we have some proposals. First, integration. Digital twin is in nature an integration of different disciplines, such as computer and software engineering, plus architect, plus construction, plus manufacturing, plus power supply, and so on. Standardization. Standardization of relevant data format, modeling parameters, interfaces of modules of digital twins, etc., are urgent need for digital twin development and applications. Regulations are also needed to provide applications of to promote applications of digital twins in different sectors and ensure its proper usage with safety, resilience, and privacy protection. Education. Digital twin should be introduced into engineering education in campus, but not only in campus, also in service training. Last but never the least is collaboration. All of these needs cooperation between disciplines, between engineering and governments, between academy and industry, between nations. WFEO is looking forward to working with all of you together to advance the United Nations 2030 Sustainable Development Goals by accelerating digital transformation in way of effectiveness, efficiency, inclusiveness, eco-friendship, and responsibility. With this, I stop my talk. Thank you very much.
Yeah, great. Well, that was good. And actually, I think if Terrence McConnell is still online. Terrence, I see you had a question earlier talking about data, and I hope a couple of the slides that Professor Gun Ku put together may have addressed just the importance of the underlying information that that needs to go into these digital twins. Next up is Peter Parslow. So Peter, if you could join us, chair of ISO TC 211, which is geographic information, and we'll turn the podium over to you.
Thank you, Barbara. So hopefully people are seeing me and soon my presentation as well. So I'm Peter Parslow. Since the beginning of this year only, I'm chair of the ISO Committee for Geographic Information. Everything in ISO comes with numbers. So I'm happy to be presenting to you. So we've just started in these last year or so to have a partnership with WGIC, which we think will be a valuable way of us understanding more about some of our users, the market in that sense. So last year we ran a project inside our committee, but consulting with others too, to look at how we can better serve the community who are trying to make their cities and communities more sustainable. So that's usually considered to be the smart cities community, but some of the cities will tell you, no, smart cities is a technological solution. What we want is sustainable. And that can mean a lot of things. So for one example, in Wellington in New Zealand, they used their sensors and location in order to detect when glass had been broken. And by sending people to clean that glass up, they managed to reduce the number of visits that children were making to hospitals, because there wasn't broken glass in the street in the areas the children wanted to play. Whereas in Rotterdam, it was more about the humidity in the foundations, because Rotterdam is a very low-lying city, and they need to make sure, interestingly, that the foundations don't become too dry, because then the building's danger of collapse. So what we came up with internally, and this isn't a standard definition, this is a definition we're using internally in a standards body for the moment, but to say that a digital twin of a city is a tool that a smart city can use to help it achieve its objectives. Now, actually, it's not all about cities. So we know there are smart parks. so who were looking for a digital twin of a national park to help them track the movement of species within the environment. And actually, there are digital twins of the weather forecasters use. And those, in a sense, are digital twins. They're using technologies that have been around longer, perhaps, but they're saying, you know, this is our constantly evolving model based on lots of sensors from which we attempt to predict what the weather's going to do next. And they are generally getting better at it. But in the sense of a city, so this might be they're going to want to be more financially sustainable, socially, like not injuring children's knees, or environmentally sustainable. That's a big one for the moment, obviously. So you've probably heard Isaac Newton quoted as saying that if he saw further, it's because he stood on the shoulders of giants. And we believe that standards, particularly open standards, that they can be the shoulders on which innovation can stand. And in particular, we want to ensure that our geographic information standards are on top of the current generations of IT standards. So actually with OGC, who you'll be hearing from next, we're working to move standards from, say, a 20-year-old web architecture to a contemporary web architecture. So they work better with contemporary web IT standards. But obviously there is other IT than the web, and where possible, we're building on those things as well. So we need to be constantly listening in our community to those communities on whose shoulders we stand. And then we see that application areas, whether that's smart cities or intelligent transport and so on, stand on the shoulders of our standards. So we've got standards that you won't even need to know about, or standards that you'll just assume exist, like how someone earlier mentioned reference frameworks. So how do you tell that this little group of numbers represents this place in the world? And while that place in the world is moving slowly with tectonic drift, and of course the planet itself is spinning and moving quickly through space. So we have the standards that do that. And you probably don't need to know more about them than they exist, and someone in each country and region understands how to get from what the satellites are telling you about your position to what that means on the surface of the Earth, or under or above the surface of the Earth. But we have other standards that you might be more actively wanting to use if you're building these sort of domain models. So it is all, as been said a lot of times in the report and elsewhere, it's about collaboration. So I thought to flood the screen with the sorts of people who are involved. So as an ISO committee, our members officially are national standards bodies. So we have about 35 countries very actively involved and some others less so. But each of those national standards bodies represents a collection of members as well. So they're commercial consortia of things like the World Geospatial Information Council and others. They can be government departments, professional bodies in the UK. You've probably picked up from my accent where I live. Our national standards body has people from the Royal Institute of Chartered Surveyors, and we have our own AGI, Association for Geographic Information, professional body of GIS people. So they get all those inputs from the technology side, in that sense, the professional bodies and the commercial consortia, but also from the government departments, the local authorities, of saying what it is they want to achieve. So TC211 works closely with that range of other standards bodies. The de jure ones, as people call it, the ones that are a bit like UN organizations like my own, and the more commercially focused ones like OGC and the World Wide Web Consortium, but also less formal ones. So we're building good relationships with those organizations that develop standards that just work without having to be done through the system. So some of those are very mature organizations and some are much newer. But we also have input from lots of user organizations, so defense and satellite agencies through to the oil and gas industry, who've wanted for a long time to be very precisely sure where their oil rigs and where their gas pipes and so on are. So they know they want to build on this common geospatial standards. So we've been working closely with OGC for about 25 years, and you'll hear more about them from Nadine next. We are very international. It's interesting to see the feedback from that report. I think covered a similar thing with yes, there's a lot of North America and Europe involved in our group. Obviously, like most maps, Russia occupies a large space. They're currently not engaging with us for political reasons, but they've generally been welcome as members, and we hope they'll be back. China, South Asia, Australasia. We're also in discussion now with several new organizations to us in North and West Africa, other parts of South America, and in Nepal, this little grey slice in the middle of Asia. So we're trying to make sure we listen to wider and wider cross-section of potential users. So another way of looking at that web of engagement, the people who partner with us in building these standards, is they come from all different sorts of organizations. So there are ISO committees to the left of this slide, and there are user organizations to the right, WGIC, representing some quite big companies. OSGeo is more the sort of small company developers who prefer to work in open source models, and we have partnerships with them too. So, and I think we could say that the two of us in the middle, TC211 and OGC, try to sit in the middle of that. So the ones to the right were more OGC relationships that we're now building into, but open and agile smart cities. So I said before, we tend to see at the city scale that a digital twin is a tool for a smart city to use, but we do take that point that a digital twin is a very specific tool that then can add very particular value above other things that a smart city might be using. This is a much more detailed slide covering the whole raft of ISO committees that we relate to in order to try and get a good understanding of the area we're trying to work in, and to deduplicate, to stop trying to create standards for the same things. So we're working closely to remove some places where we've realized we've created a standard that really should be managed by someone else, and we're hoping that they'll return the compliment by not creating additional standards that overlap into our space. Another example, there was in the report a well-made point that it can be very helpful to know that two things are in the same place at the same time to a degree of tolerance that means you can be sure they're the same thing. The maths of how come different IT systems will agree that two things are in the same place, again, is one of our standards. But we have found that other areas like intelligent transport generated their own interpretation of how to solve that problem, and then you can get slightly different answers. So someone once said, the great thing about standards is that there are too many of them, and that, of course, is not a great thing. So part of what we're doing is trying to consolidate down to get the set of standards that actually work together. Now, this is a very complicated picture, as was the one before. So what we have realized as a result of our engagement last year is that what we need to do as the standards bodies is to provide more like introductory guides. If you are a city leader, a city data officer, what do you need to know about geospatial and which standards should you be using, rather than just saying we have 100 standards, take your pick, which has been the approach so far rather. So I'm hopeful that in the next year or so we'll be producing a few specific guides saying, if you're looking for standards to help with the spatial digital twin, here are some that we've proven that work together. Now, we won't be doing that by ourselves, very much with OGC, probably with WGIC, probably with W3C as well, the World Wide Web Consortium. So that was a set of slides I have. I've lost track of whether I've spoken for more or less time than I was asked to. Partly my clock has disappeared while talking, but there you go.
No, you did great, Peter, thanks. And thanks for weighing in on the smart city digital twin issue. It was great. You had a slide ready to go for that.
It's a view anyway. Not
right.
necessarily the official answer. Yeah.
All right. Okay. Let's see. Oh, great. Some contact information there for folks. I'll give you just a couple minutes to take a look at it. And then we'll have you stop sharing, and I'll introduce Nadine, Alameh, Executive Director of the Open Geospatial Consortium. Nadine, thanks for joining. And based on the Twitter feed and the LinkedIn feed, I believe everyone in the world knows this, but for those of you who don't know it, Nadine has been elected to an advisory seat on the National Geospatial Advisory Council here in the United States. So Nadine, I know that's a competitive trade space to be working in, so congratulations on that. You'll do a wonderful job. We'll turn it over to you.
Thank you so much. I really appreciate the introduction, and if Anne or Leah can actually do my slides, because my laptop is not letting me. I have to restart, and I really don't want to restart.
Okay, just give me a second there.
Thank you. Thanks. But yeah, thank you, Barb, for the introduction. Thank you for inviting me to be here. And thank you, WGIC. Congratulations, WGIC, on the release of this report. So while the team is getting my presentation, if you know me, like Barb said, on whether it's Twitter or on LinkedIn, I can't. Yeah, oh, it works. Thank you so much. So I can't. Next slide, please. I can't usually hide my excitement about where we are as a geospatial community of experts, of users, because there's never been a better time to be in geospatial. And I think that the spatial digital twins that we're talking about here and the topic of the report are in many ways what has been in our heads for a long time, since we started using GIS a long time ago. But I think it's just now the world has caught up to us finally. I always say, actually, geospatial, we've been ahead of the curve. Now the technology, whether it's space, whether it's sensors, whether it's cloud, the innovation, the consumer readiness for what we can do, I think all of this, they finally caught up with us. And that's why we are able to talk about the spatial digital twins on the hype cycle. And I think key to all of that is, at the end of the day, as to with everything, to be honest, is data integration, system interoperability. And I was very happy to see in the report, the word standard was actually repeated 60 times throughout the report of like 78 pages. So it's almost once a page. And I think that's how important standards are to creating not just a one-time spatial digital twin of something, but actually a sustainable over the long term. So I'm happy to follow Peter. He said a lot of things, speaking of building on the shoulders of giants. I'm going to build on Peter's shoulders. So next slide, please. When I think about, as OGC, everything that we have been doing in the last 27 or so years really supports this reality of spatial digital twins, not the dream, not the vision, the reality. I think we have always been about collaborations across the domains, across regions, across government, private industry, academia, other standards bodies. I think geospatial people are collaborative just by who we are. Currently, OGC is more than 550 member organizations, a small sample shown here. And we're collaborating information that has a geospatial component to it, findable, accessible, interoperable, and reusable, fair. And I think fair is key to sustainable spatial digital twins. As per Peter, we've always, as an outcome of collaborating to solve problems, we've delivered standards, international standards, the glue, sometimes they call them, but also more equally, and Peter said that as well, and I appreciate it a lot, as important as the standards are the best practices on how to use, how to apply, or how to extend, or how to combine those standards for your problem, for your domain, for your digital twin. So in many ways, to me, we talk about, collaboration, standards, and impacts in OGC, and the spatial digital twins parallel that very nicely. Collaboration, standards, and impact. So next slide, please. So I said to myself, in preparation for this talk, let me look at the list of OGC standards and just share with the audience what OGC standards are relevant to spatial digital twins. And then I quickly realized that it's impossible because they are all relevant. So I'm going to spare you and not go through them. But if we go to the next slide, I can just pick a few so that you know how really everything that we've been building over the last 3-5 decades actually got us to this point. Think about if you can click please, city modeling that we have, city GML. Next click is we have standards for the streaming of 3D data. If you click one more time, we have other models. I appreciate Jeff Zeiss earlier talking about underground infrastructure modeling, because you need all these models for digital twins. If you click one more, you'll see indoor mapping, because that's also part of it. I can go on with respect to the models, but another click and we'll quickly get to, we need the standards to pull the live data from the sensors. So I appreciated the earlier overview of the report when they were talking about this combination of all this data, sensors. Next click is the efforts of this community. So I appreciate, buildingSMART as well, trying to bridge, I call it once and for all, the geo world and the BIM world, because you need that for spatial digital twins. Another click, Peter mentioned the modernization of the foundation. These are the APIs for us, the building blocks of the future of geospatial. And maybe another click, we're trying to lower the barriers, in this case, modeling and simulation, because you need all of this, right? That's why it's so hard to define what spatial digital twins are. And that's why I appreciate the report, because it has that, at least there's a source for all of us to refer to about what we mean and what goes on behind urban digital twins. And I think one more click, speaking of community, we've been engaging in how do we support smart cities and domain working group. And by recently, I mean in March, we've rebranded in a way, actually we've restructured, reformed the Smart Cities Domain Working Group into an Urban Digital Twin Working Group. And I saw a question earlier about that. So I think we're all in sync here. So next slide, please. I think I can go on, but you can see here that the work of the geospatial community contributes everywhere. Energy and utilities, emergency, disasters, security. And I'm showing here the working groups, the domain working groups, not the standards, the domains, the communities that come together for the best practices. And one more click, all the way to recently, we've even started to have conversations about a Metaverse working group. And this working group is like pulling the digital twins, the modeling and simulation, the 3D communities, the sensor things and the sensor stuff, and on and on. So you can see how, you build those spatial digital twins. And in this case, the metaverse as this encompassing environment that also includes the social interactions. So I told you there's no better time to be in geospatial. So two more points, one click, please. Two more points I'd like to point out. One point is the work of standards is never done because as we scale, the twins, there's the twins of the earth and there's the twins of the universe very soon. So as we scale, as we continue to innovate, comes the need to create new standards. And then, examples are like the cloud native geospatial, we mentioned the APIs, even the geo AI, the artificial intelligence, I can go on, which in turn, once you have stable standards, they enable more integration, more applications, more innovation, and then you need new standards, and that's the circle of life. So that's one point. The work is actually not done. That's why I appreciate the report calling for more engagement, more collaboration. My second and last point is I want us all to always keep in mind, one click please, the ethical use of location data in the context of everything, but in this case of spatial digital twin. That's the reason why OGC was one of the first organizations that signed the Locus Charter. And I think that's something that's important to keep in mind as we build and evolve, the spatial digital twins. So one more click, and all I can say, congratulations again on this report, on this event, for actually enabling community dialogue. And thank you for inviting me to contribute on this ride towards spatial data, spatial digital twins. So thank you, Barb, again, and back to you.
Great, thanks. Thanks, Nadine. And again, I hope folks got her email address on that last slide if you wanted it. Nadine, thanks. Those were great graphics, and thanks for weaving those all together, and also talking about the job of standards is never done. Listen, let's turn it over to Tony Rinella, Senior Director of Strategic Building Innovation at buildingSMART. And so Tony will turn it over to you. And again, I think there already have been some great comments in the chat from the early session and Nadine's reference to just the importance of the built environment. So delighted to have you with us today. Thanks.
Greetings. Well, thank you very much. I'm Tony Rinella, speaking on behalf of buildingSMART International. We're delighted to be a strategic partner of WGIC. We thank you for this opportunity. As we've heard, reliable standards and data sharing are essential to unlock the economic, social, environmental, and business value for the built environment industry. buildingSMART is committed to the development and adoption of international open standards and solutions. We encourage you to download and review this buildingSMART paper on digital twins so that you can see some of our recent thinking and efforts. As Nadine said, good practice is important. And Thomas Werner said earlier, the future is not too far away. We're going to put those two ideas together by sharing some exemplary projects that help us see how open standards are working in the real world, even as we speak. The first project is this buildingSMART award-winning project. It exemplifies the importance of open standards for successful digital twin in real-world projects. The Hamburg Smart Bridge digital twin is used to monitor the physical health of the structure in real time and provide early warning of potential difficulties before they become critical. Let's hear them talk about the project in their own words.
Smart Bridge Hamburg innovates the maintenance of bridges. In the form of its digital twin, the Kohlbrand Bridge is brought to life to get real-time condition information and perform predictive maintenance. The BIM model is the backbone of the digital twin and connects data coming from classical inspection, monitoring, and structural diagnostics. OpenBIM enables the interdisciplinary team to collaborate in making BIM the hub of the bundled data stream. Aggregated condition information is visualized in a user-centered platform. the user can choose between explorative navigation or guided tours to get a quick and complete overview of the situation.
SmartBridge Hamburg becomes a global reference, extending the use of BIM and IoT to the operational phase of bridges.
SmartBridge Hamburg, the future today.
So, as Mark Werner said, open standards help to make an elegant, affordable, and reliable solution possible. This project used industry foundation classes and BIM collaboration format to achieve interoperability between diverse applications. Moving to the vertical construction industry, this project is for the International Commerce Center in Hong Kong, where open standards can provide a backbone to manage many aspects of a very large structure. The building has one of the largest IoT networks in the world, and they are linking it to a 3D model. This diagram for a similar project, which is a collaboration between Strategic Building Innovation and Sun Hung Kai Properties, demonstrates the vital role of open standards in connecting physical connections, streaming sensor data, and, quite importantly, systems used to manage decisions, planning, and follow-up actions. This innovative network was developed to ensure that accurate digital information drives appropriate follow-through in the real-world built environments. We invite you to join our upcoming annual Open Standards Conference to learn and to voice needs and to contribute to the solutions that we're developing for the future. Thank you.
Tony, thanks for that. And then last but not least, we'll go over to Dr. Anaroot Roy, Chief Technology Officer at Genesys International. So Anaroot, thank you for joining us.
Yeah.
We'll turn it over
to
to
Barbara. Thank you so much. Let me share my screen. Okay, thank you everyone. So currently my present aspect will be revolving around the Indian perspective, which is the topic we have chosen today, is urban spatial digital twin. So here I'll be representing Association of Geospatial Industries, and I'll also be speaking about the initiative that we as Genesys we have taken in India by proactively launching our own content program for 100 cities of India to create a digital twin on our own. So that's the background. So briefly what I'll be talking about, just to introduce to all the fellow participants about the AGI activities in one slide, just to give a very high level picture about the Indian geospatial economics. Our current understanding in the industry as well as in the government, what we would like to do and what digital twin can provide us, the roles the standards play, and the program that we have launched on 1st of December 2021, what is that our approach is all about. And I'll show a small video specific to the proof of concept that we have done in the city of Mumbai. So as Association of Geospatial Industry, we do a lot of global trends and market focused, all revolving around the industries in India. We play a great role in putting our voices of the industry. We work very closely with all the stakeholders like the government, academia, industry, and we regularly publish our newsletters, journals, and white papers. In addition to that, we have recently started our skilling program, where we feel that capacity building is very, very important, and we draw the people from the industry and see to that specific to the data acquisition, survey, data processing, how the different industries can be put together and how the skilling aspect can be generated. One of the recent aspects concerning to the economics, there is a published report by Geospatial World, which talks about the Indian geospatial market. The government of India in 2019 has an aspiration of bringing this Vision 2030 to become a USD $5 trillion economy, and by 2030 to become a $10 trillion economy. It has been largely felt that in order to accomplish that, it is very important to bring reforms in the current policies, as the geospatial market is expected to grow at 3.39 CAGR. And we'll talk about what are the policy reforms the government has created, which has now brought a lot of vibrancy within the Indian geospatial system. Many of you may not be aware that in the year 2015, Government of India has launched a smart cities mission. So 100 cities of India has been chosen very carefully based on certain parameters, and that is a proposal. There is a round of participation. There was a collaborative program. Through a very sound selection process, the system integrators, the solution providers have been selected, meeting the objective, in which the participatory form of the citizens also being taken into account. $6,400 million actually has been the central assistance, and 5,000 plus projects have been allocated. So as you can see here, the Smart Cities mission, which primarily constitutes about the smart mobility, smart people, economy, environment, government, IoT devices, smart living, large control centers have been created, and I could see, and I can talk on behalf of the industry, in the recent COVID time, all these control centers have greatly provided support to all the citizens and all the first responders to mitigate the disaster. One aspect is very important, that when we talk about the smart cities, it has been very carefully designed that city-based initiatives are only 20%, whereas area-based development constitute around 80%. So when we talk about the smaller area, how the things can operate or interoperate, this is where we found that a lot of area-based development projects are actually getting the importance in the ambit of this project. Ministry of Information Technology, and under that we have got one specific National Informatics Center. They are our IT backbone, and as per them, they have defined digital twin, and the definition is evolving, but just for the setting the context, I felt, let me put it across. So prima facie, when we talk about digital twin, the basic understanding is that a 3D digital model, which is linked to the real world system, but it lacks intelligence learning with a limited functionality, which is operating as a CT model. Then on top of that basic model, we bring in the sensor data. And then in some capacity, the feedback and the controls are actually coming. So in that aspect, one will know definitely sitting at the control room, what is the temperature of a specific building, how much of energy is being consumed by that locality if you get automatic meter reading. So that's a sensor digital-based digital twin. Then we have got this real-time communication, wherein we can learn very efficiently various sources of data around the surroundings. And that is where the commute part of the mobility comes, and various apps, signages, radio, that allows the drivers to better plan their journey. So this is another aspect of the digital twin. And now we envisage that all this is going to happen in the 3D environment. The fourth aspect is about the predictive part of it. The digital model is about to do the predictive maintenance, specifically for many of the infrastructure projects, where we found that what is the life of this infrastructure, be it dam, be it a railway infrastructure, the roads, how much is the corrosion, and those are the work actually now started playing into the game of digital twin. Last but not the least, and this is the evolving system, about the artificial general intelligence, where we emphasize that in the 3D digital model, ultimately approaching the ability to autonomously reason and to act on behalf of the user. A simple example can maybe the autonomous driving or the autonomous vehicles. With this understanding, let me put it across the kind of reforms in last 1 decade that the government of India has brought specifically for the geospatial industry. So way back in 2012, we realized the data sharing is become a very, very important issue because those are primarily in the silo. So this policy empowered that the government departments need to share their data, which is in their possession. 2012 remote sensing data policy, and then the cloud computing, then the artificial intelligence. These are the series of strategy papers which have been brought in. And then space-based policy has come in 20th November 2020. But the most landmark policy, which has the very revolutionary aspect, as far as the Indian geospatial industry is concerned, is in 2021, 15th February. What has happened that all the restrictions, industry is now allowed to freely capture the data of very high resolution. That means the Indian entities within the geospatial industry will be in a position now, in fact, we are capturing that, aerial data of very high resolution, which was otherwise restricted due to the security reasons, perhaps rightfully, but now all those bars have been removed. And that is what is bringing a plethora of opportunities. National geospatial policy draft has come, and we anticipate that in next 1 month, the final policy is going to be rolled out. And then similarly, around 30,000 drones registered in India. So that is the kind of vibrancy we see here. As far as the interoperability is concerned, and it is very, very important that when we talk about 100 smart cities or 500 other town planning Anaroot cities, so there are multiple urban infrastructure projects which have been rolled on. We adhere by and large that at a national level, we have got a national spatial data infrastructure where the guidelines are very clear. There are multiple mapping national organizations, and we also adhere because Bureau of Indian Standards that acts as a basically for the TC211, which Peter has now told, we have co-branded many of these ISO things. And it is not only co-branding, we have been part of it and we have been actively involved. And whenever there is a requirement, we advocate the government to include this in their request for proposals or the RFPs and the tenders. As far as the OGC is concerned, I think it is a very common name now in the most of the government tenders, and the customers, the stakeholders of the geospatial industry very frequently now use WMS, WFS, WFST, and CTGML. One of the other aspects, which is more on the IT part and which is very closely linked with our geospatial, is this kind of policies or the guidelines which are issued by the Ministry of IT. So when we take up any project, any IT project, GIS become a part of it, then we need to adhere to all the systems subject to the terms and conditions of the scope of the project. One of the aspects, and which is again very, very welcome step by the government, is that it has mandated that all the government data should be in the open environment. And a platform has been created which one can access, and proactive release of the data sets through the API of the various government entities. And anybody, whether it is a startup, whether it is an individual, whether it is the programs which are there, the industry-led initiatives, innovative use of this data set can be done, and that is going to help and govern. One of the other aspects the government has done for the geospatial industry, that all the aspects within the various ministries has now put as a dashboard or in the form of a report card. So one would know how many resources are there, how many catalogs are there, and this has been made very, very beautiful. The main aspect of the digital twin, and this is the crux of it, that why as an industry we get so excited, that the policy document very clearly tells that we need to move from data-centric infrastructure to the knowledge-based network, where digital twins do play a role. The whole aspect is that if we get high quality, timely, and reliable data, then the national priorities will be set accordingly and will be in a position to fulfill the UN SDG programs. Very fundamental aspect, and this is the crux of the whole policy. The threshold value has been fixed. That means 1 meter horizontal and 3 meters of vertical or elevation. Any Indian entity can freely acquire, process, and disseminate data of any spatial accuracy within the territory of India. And any foreign entity can collect these data sets above the threshold level. However, the Indian entities are free to share this data with any of the foreign entities, provided there is an appropriate application programming interface through which it can be published and shared. Access of the course real-time thing, there is no bar now, and Indian entities can actually get and leverage the facilities of course. Terrestrial mobile mapping system, Street View survey, which was otherwise restricted and had lot of permission related issues, has now been absolutely smooth. So the content which one can generate through the mobile mapping systems can be accessed without getting any permission, of course, by and large some negative list which is issued by the Ministry of Defense. So Genesys, as a company, we felt that we should do immediately after the release of the policy a proof of concept. And we have studied and we have done a small work on the Worli, which is part of Mumbai. And we formally launched the program of Urban Spatial Digital Twin for top 100 cities. Basically, it is a content program where we are aligning ourselves with a lot of startups, with a lot of technology partners, urban local bodies, and the businesses. And the kind of sensors that we have got around 50 of this mobile mapping system. We have got now 2 manned aircraft fitted with a LiDAR and optical sensor and near infrared. And this is how we started our program. Our approach is very simple. We felt that these 5 elements, we should make it appropriate. First and foremost is that the data which is so far is not available, the very accurate 3D data, we are now going to acquire it for the 100 cities in the span of next 1 and 2 years. So very accurate geometry of the real world features with the appropriate geographic reference. So our data will be supported with the LiDAR, with the engineering grade maps and models, and we will go up to LOD 2, 3, 4 based on the need of the individual customers and the needs. So this will be as a subscription services. The best part is that when we have got this geometric dimension, the attributes actually brings in the intelligence. And that's where the role of the data models play a very big role. So whether it is ERP, CRM, this is all needs to be very standard based. IoT-based feeds we are getting from the probe data, the temperature, humidity, these are existing in the smart cities. However, it is not fully leveraged in the 3D environment. This is where the experiment we are now pursuing, and we are finding good success in that. Temporal changes and predictive analysis, a lot of what-if scenarios. We have done many more is in our to-do list, and we are actually working with our partners. Ultimately, artificial general intelligence, this is what we do it for the rest of the world, these HD maps, and we do a lot of AI ML automations. We have not practiced it in India, specifically with respect to the automation buildings, but we are going to start it. So one aspect I'm very highlighting this aspect. When individual smart cities.
Dr. Roy, I apologize. I'm going to ask to go pretty quickly through these next 2 slides.
Okay, so what I'll do the standardization of the data. These are the aspects which our previous responders told. I will just play the video. I think that should be fair enough, and that should bring around just one video, and that should be fine.
The time has come to make India's cities smarter. The time has come to enhance and improve all aspects of urban life. The time has come to go away beyond 2D mapping. For the first time in India, a 3D digital twin of urban India is in the making. Welcome to the mapping revolution. Genesys, a company with many firsts in the industry. The Genesys constellation. All set to create modern India's 3D digital twin. A revolutionary way to plan modern cities. With India's largest collection of sensors, remote sensing experts, comprising AI ML technologies, powered by a massive computing infrastructure, and with patented proprietary tools. Genesys has created India's most modern mapping platform, encompassing unique data layers. The 3D digital twin will be powering the next generation utilities such as telecom infrastructure, improving network coverage, and better analytics for users, solar applications, enabling renewable energy development, EV charging stations, helping citizens get access to low-cost charging, Genesys's advanced driver assistance systems, helping in bringing in the automated driving revolution to India, e-commerce, improving the speed of product deliveries. We are on a smart cities mission with new infrastructure planning, identification and inspection of road distress, green coverage assessment, emergency response, assessment of street vending activities, water conservation and flood management, property tax valuations and collections. An unprecedented platform with its exceptional functionalities, accelerating innovation in urban service delivery in Indian cities, making lives better for citizens. For the first time, a 3D digital twin of entire urban India is in the making, with a month-on-month increasing data capture capability. Using the Genesys constellation, a platform taking forward the PM's vision of Atmanirbhar Bharat, a new India, a well-planned India.
Thank you so much.
Okay, yeah, thank you, Doctor. I appreciate that. Thank you so much. Let's see, a couple things. You guys, I apologize. We're running late on time, and I don't want to pull from the next panel. I don't want to take any time away from Dan. But just a couple things. There were a couple questions that came into the chat. I'd encourage you to go to the networking session to talk to these folks directly. I'd like to thank the panelists one more time for really very solid presentations. And then Dr. Roy, there has been a request for the video. So that'll be, if you are able to stay around for the networking session, or maybe you can provide a link to the video in the chat and we'll get it to folks. So thank you. Again, thanks, Professor Gong, not with us, but Peter, Nadine, Tony, and Dr. Roy, really, I appreciate your time. To the extent that you can stay for the networking event, that would be great, because I'm sure some people would like to talk to you individually.